Good morning, students. Now HS second year mathematics, and we are doing application of derivative chapter 6, and already we have finished exercise 6.1, 6.2, 6.3 also partly we have finished, that is up to question number 7 we have finished. Now we will do question number 8. Before starting the question number 8, we have to think of that equation of tangent is what? Y minus y1 dy dx x minus x1, and equation of normality is what? Y minus y1 minus 1 by dy dx x minus x1. And here one thing you have to remember, dy dx at for the value x1 y1 is the slope of the tangent, and minus 1 by dy dx is the slope of the normal at the point x1 y1. Of course you have to replace x by x1 and y by y1. So with that concept only whole exercise we are able to do. And now question number 8, we will read this question first. Find the point on the curve y is equal to x minus 2 whole thing square at which the tangent is parallel to the chord joining the point 2, 0 and 4, 4. That means they have said in question number 8, y is what? X minus 2 whole thing square. Of course it is looking like what? 8 may be a parabola. And another thing, here tangent at a point, suppose we don't know x1, y1, we have to find that point x1, y1 where this tangent is parallel to the chord joining point 2, 0 and 4, 4. So that we have to consider during this one. Another thing, chord is this. Chord means any two point of a curve if we join, then it is what? Chord of the curve. That is also it is in our concept, so that we know only. So here chord is 2, 0 and 4, 4 are on the parabola on the curve, this one, and if we join these 2 points it is chord, and this chord is parallel to our given tangent. Now you remember that if two lines, if they are parallel, then of course both have the same slope. So slope of the tangent and slope of the chord both should be same. Now before doing this one, you have to differentiate it y. Y is what? X minus 2 whole thing square. If you differentiate, dy dx is using chain rule 2 x minus 2 2 minus 1, and then you have to differentiate x minus 2 again. So ultimately we are getting 2 x minus 2. This is our dy dx. Now slope of chord. What is the slope of chord? Now we know slope of chord is what? Y minus y1 minus y2 by x1 minus x2. What is x1 and y1? What is x2 and y2? x1 y1 is one end point, that is one point of meeting point of chord and this one, and x2 y2 is the another point. Now here x1 y1 we can consider as 4, 4, x2 y2 you can consider as 2, 0. So what we can write here? 4 minus 0, 4 minus 2, ultimately 4 by 2 is 2. So slope of the chord, what we get? It is 2 only. Now what is the value of dy dx? Dy dx is equal to 2 only. It is according to the condition that both are parallel. Given what? Chord and tangents are parallel, that means slope of that one tangent is dy dx, slope of the chord, that is 2, both are equal. So dy dx they have given 2. This implies dy dx is, we have calculated 2x minus 2, it is 2. We can cancel these 2. Ultimately we can get x minus 2 as 1. This means x is what? 3. So it is what? What is the value of x? X is 3. Now for x is equal to 3, y will be what? 3 minus 2 whole thing square, that is 1 square is. So required point of contact, what we have able to find, this one is 3, 1. So therefore required point of contact, and it is what? 3, 1. So this is the technique of solving question number 8. So now we will move to question number 9. So what is question number 9? Question number 9 like that. Find the point on the curve y is equal to x cubed minus 11x plus 5 at which the tangent is y is equal to x minus 11. Equation of tangent they have given, and we have to find the point of contact. One thing I want to make it clear, one sum has so many procedure. So if we solve these two equations, then also you can get the point of contact. But both the contact may not be the point of contact for tangent, but it is the one of the technique I am telling. But as it is a application of derivative chapter, tangent and normal, definitely you have to use the that is formula and all these things, techniques of derivative. So let's start the question. Question 9 is y is what? X cube minus 11x plus 5. And equation of tangent they have given what? Y is equal to x minus 11. So what is the technique behind here? Now if we differentiate this one, it will what? Dy dx, that is slope of the tangent. Another thing, that if suppose one straight line is y is equal to mx plus c, then m is here slope of tangent. So here also slope of tangent of this line, that is what is tangent it is 1 here, because if we convert it in the form y is equal to mx plus c, coefficient of x is 1. So here slope of tangent is 1. Now if we differentiate our given, this one will be equal to 3x square minus 11. X cube's differentiation is 3x square minus 11x. Actually minus 11 is constant, it will remain outside. X is constant, it is x is what? Differentiation is 1. So we will get this one. Slope of the given tangent, this is what? 1. Why? Coefficient of x is 1. We know if a straight line is y equal to mx plus c, then slope is what? Slope is m only. So here also slope is 1, as it is the coefficient of x is 1. Now see, dy dx it is what? Slope of tangent. Here slope of the tangent what is given is 1. That means dy dx they have given 1. So according to the question, dy dx it is what? It is 1. This means that 3x square minus 11 is equal to 1. Implies 3x square is 12. So we get x square as 4, implies x is what? Plus minus 2. So we are able to find the x coordinate of point of contact. For x is equal to 2 plus 2, y becomes 8 minus 22 plus 5. So is minus 12. Sorry, 8, 5, 13. So I think it is 9 only. Minus 9 only. So that is, and for x is equal to minus 2, y will be what? Minus 8 plus 22 plus 5. So it is 30 minus 8 is 27. So it is I think 19 only. Therefore required point of contact, it is 2 minus 9 and another is minus 2 19. So these are 2 point of contacts we get in this location. So this is our question number 9. Now we will move to question number, next question, that is question number 10. Question number 10 is like that. Find the equation of all lines having slope minus 1 that are tangent to the curve y is equal to x minus 1. That means in this question they want to say that y is equal to x minus 1, you can draw so many tangents at the different point of contact. Now at the, so here all the tangent they are not asking, they are asking the equation of the lines having slope minus 1, that is tangent and are tangent to the curve. That is, we have to find the equation of those tangents whose slope is minus 1. Okay, nice. So point of contact also not given. So question number 10, that curve is given y is equal to 1 by x minus 1 and slope is given what? Minus 1. If we differentiate this one dy dx, then it will be what? Minus 1 by x minus 1 whole thing square. If we differentiate x minus 1 by x minus 1 to the power this one, this is by the formula of this one x minus 1 whole thing to the power minus 1. So minus 1 x minus 1 to the power minus 2. So that actually gives this one. Chain rule also you have to use. Any problem, that is differentiation you have to know nicely. If you don't know the differentiation, then application of differentiation that you cannot do easily. So given what? Dy dx, this one is minus 1. Actually what is our next target? It is what? To find the point of contact. Then we can able to find the slope of the tangent. If dy dx is 1, then 1 is equal to minus 1 by x minus 1 whole thing square. Implies x minus 1 whole thing square is, I think minus 1 minus 2 equal to this 1. So we get x minus 1 is equal to plus minus 1. Ultimately we get x equal to 0 and another is what? 2. So we are getting 2 points of x coordinate. For x equal to 0, what we get? Y? Y, yes, of course it is minus 1. And for x equal to 2, y becomes 1. So we are getting 2 point of contacts. So as we get 2 point of contact, so of course, how many tangents will be there? 2 tangents will be there whose slopes are minus 1. Therefore, equation of tangents, it is y minus y1, it is minus minus 1 plus 1, minus x minus x1, that is x minus 0, that is this. So this is one of the tangent. And another is what? Y minus y1 is equal to minus x minus x1. So this is the equation. This implies x plus y. If you take x in this side, plus 2 minus 1, it is 3. So you get what? X plus y plus 1 is equal to 0. So we get 2 equation of tangents whose slopes are minus 1. Now, these are the technique of doing question number 10. Now we move to question number 11. So these are not so tough sums, so you can do it easily if concept is clear. Question number 11 is like that. Find the equation of all lines having slope 2 which are tangent to the curve y is equal to 1 by x minus 1. It is also similar like that. Curve is given y is equal to 1 by x minus 1. So x minus 3. And slope it is given dy dx is, dy dx they have given, it is 3. Similar like that. Condition that equation of tangents you have to find whose slope is 3. If we differentiate this one, this will be what? Dy dx is minus 1 by x minus 3 whole thing square, and then differentiation of x minus 3 is 1. So you see that differentiation of this one, that is the technique by using the chain rule. this can be treated as x minus 3 to the power minus 1 by the formula divide dx, dx to the power n, dx is what, nx to the power n minus 1. So minus 1 x minus 3 to the power minus 1, that is minus 2. Then differentiation of this one by chain rule. Just you have to do this one. Given it is what, dy dx is 3. This implies minus 1 by x minus 3 square is 3. Slope of the tangent they have given as, I think slope they have given, it is 2, I think. So it is 2. They have given. This means that x minus 3 whole thing square is minus half. Then, now it is a contradictory one. See, x minus 3 is plus minus root over minus 1. As it is given, slope of the tangent is what? 2. Problem creates here root over minus half. That is the imaginary number. And we are application of derivative. Of course, we are considering all the things which are real. So, not real. So, we are getting value of x which is not real. That is, if we take 3 in this side, then this is a not real number. Therefore, we cannot get tangent having slope. So, as it is with the given condition, therefore, there does not exist any tangent. Any tangent means tangent having with that condition. So students, this is our the question up to question number this of exercise, question number 11 of exercise 6.3. I think you understood it nicely. So with that we end our today's class.